Hi everyone, it's Mr. Baker here, and today we're going to be doing another physics video. This one's all about models of the atom. Okay, so we're going to be looking at scientific models of the atom today, and we're going to be answering this question: how many atoms wide is my finger? So let's go back in time. Let's look at the ancient Greeks and what they had to say about all of this. So in 500 BC, ancient Greek philosophers like Leucippus and Democritus proposed the idea that if you keep chopping an object in half and half again, you will eventually come to an object that can't get any smaller. The word atom comes from the Greek atomos, meaning indivisible. In other words, it cannot be divided anymore. So that was our first sort of theory of what an atom might be, or what the smallest thing might be. Now, John Dalton was born in 1766. He was an English chemist and physicist. And in 1803, he expanded on the ideas of the ancient Greeks by proposing that not only were atoms indivisible, but that they were tiny spheres. An element's atoms were identical, but different elements were different, and compounds were made from combinations of different atoms. Sir Joseph John Thomson was born in 1856. He was a British physicist and Nobel laureate in physics. And in 1897, J.J. Thomson discovered electrons in atoms. In 1904, he proposed the plum pudding model of the atom. It was not a solid sphere as Dalton had thought, but a cloud of positive charge where negative electrons were scattered amongst it. In his model, the pudding was like the cloud of positive charge, and the plums were like the electrons. So it was like this amorphous blob. It wasn't this solid thing, so things could probably pass through it fairly easily. Ernest Rutherford was born in 1871 in New Zealand. He was born to British parents. He was a physicist who became known as the father of nuclear physics. And in 1911, Ernest Rutherford carried out his gold leaf scattering experiment with assistant researchers Hans Geiger and Ernest Marsden. He fired positive alpha particles at a very thin piece of gold leaf, expecting to confirm J.J. Thomson's model of the atom. Instead of all of the alpha particles passing straight through the atom as expected, they discovered that a few deflected large angles. This would only happen if most of the atom was empty space with a small, dense, positive centre, the nucleus. So let's look at that in a bit more detail. So this is an animation of Rutherford's experiment. Rutherford asked Geiger and Marsden to perform a series of experiments, pointing a beam of alpha particles at a thin gold foil and measuring the scattering pattern by using a fluorescent screen. When Geiger and Marsden shot alpha particles at the gold foil, they noticed only a small fraction of the alpha particles were deflected by more than 90 degrees. Most flew straight through the foil. This suggested that those tiny spheres of intense positive charge that were separated by a massive amount of empty space. Most particles passed through the empty space and experienced hardly any deviation, while a handful passed close to the nuclei of the atoms and deflected through large angles. So Rutherford rejected Thomson's model of the atom and instead proposed a model where the atom consisted of mostly empty space, with all of the positive charge concentrated in its centre in a very tiny volume, surrounded by a cloud of electrons. Rutherford famously said that it was as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. So here you can see alpha particles being fired towards an atom, a gold atom, and you can see that the vast majority of the alpha particles are going straight through, but they're being deflected. They're being deflected because the alpha particles are positive and the nucleus is positive. And as we get close to the nucleus of the gold atom, you can see that some of the particles are getting deflected. And in rare occasions, those particles are getting deflected by more than 90 degrees. So that wasn't the end of the story of the atom. We now move on to the modern atom. So Niels Henrik David Bohr was a Danish physicist born in 1885. He was a student of Rutherford's and developed a new model of the atom. He proposed that electrons are arranged in concentric circular orbits around the nucleus. The electrons can move between energy levels. If they gain a packet of energy, they move up an energy level. If they move down an energy level, they give out a packet of energy. These packets of energy are called photons. And so now we move on to our last model at the moment, the modern atom. Erwin Schrödinger was a Nobel Prize-winning Austrian-Irish physicist born in 1887. In 1926, he took the Bohr atom model one step further. The quantum model does not define the exact path of an electron, but rather predicts the probability of the location of the electron. This model can be described as a nucleus surrounded by an electron cloud. Each step on the way to our most modern idea of what the atom is, new evidence has replaced our old ideas because they explain our observations better than before. This is what happens with scientific ideas over time. As new evidence becomes apparent, old theories make way for new ones, themselves ready to be challenged as observations and evidence do not fit within them. And so we come towards the end of the lesson, and these are the things that you should be able to do. So you should be able to describe how our ideas of the atom have changed over time. You should be able to identify the Rutherford model of the atom and identify locations of protons, neutrons and electrons. You should be able to describe in detail the plum pudding model of the atom and the evidence from Rutherford's scattering experiment, and describe the properties of protons, neutrons and electrons. You should also be able to explain how new evidence helps to reject the one model for another. So let's look at our question then. So how many atoms thick is my finger? So the radius of an atom is 1 times 10 to the minus 10 meters. So if my finger is 1.5 centimeters wide, how many atoms is that? So if you want to have a go at this, just pause the video there and have a go, and I'll go through the answer now. So if the radius of an atom is 1 times 10 to the minus 10, the diameter of an atom is 2 times the radius, so that's 2 times 10 to the minus 10 meters. 1.5 centimeters equals 0.015 meters. How many atoms wide is my finger then? So the width of my finger divided by the atom's diameter equals 75 million. So that's been our lesson on models of the atom. I've been Mr. Baker, and this has been another physics video, and I will see you next time. Thanks very much.